Hello everyone, welcome to BOSJOB's channel. When working with TIG welding, you might sometimes run into a problem, that is having difficulty starting the arc. This difficulty can show up in various ways. Sometimes when you press the torch switch, there's no output at all. No argon, no high frequency, no arc, nothing at all. Sometimes there's gas and high frequency, but still no arc can be established. Other times there's gas, high frequency, and an arc, but the arc breaks off shortly after it starts. As I mentioned earlier, welding issues come in all sorts of varieties. With TIG welding, you have a power source, a torch, a workpiece, a ground clamp, a tungsten electrode, and gas. So, where's the problem? Sometimes it can be tough to pinpoint, right? Today, I'm going to show you how to troubleshoot step by step. Let's get to the bottom of the issue. First, let's quickly go over the correct procedures. If you think you're already familiar with this, feel free to skip ahead, but it's best to watch patiently. 1. Make sure the machine's power is connected. Check the voltage and phase requirements on the machine. Use a multimeter to check that the voltage and phase match before turning the power on. 2. Connect the torch and ground cables according to the polarity symbols on the machine. The TIG torch is negative, and the ground cable is positive. If you reverse them, it will burn the tungsten rod. 3. Make sure the connections for the torch and ground cable are tightened securely. For air-cooled torches, ensure the gas connection is tight. For water-cooled torches, ensure gas and water inlets/outlets are secure. 4. Make sure the torch switch connector is fully plugged in and secure. 5. Check the shielding gas. It has to be argon. CO2 or nitrogen won't work. Open the main valve on the gas cylinder and check if the pressure gauge shows that there's enough gas. If it's running low or empty, make sure to replace it. If there's enough pressure, close the main valve for now. 6. Connect the gas hose to the machine's gas inlet and make sure it's secured tightly. Open the main valve and the flow meter valve. The floating ball in the flow meter should rise. After a moment, the floating ball should drop to the bottom, which means the line is filled with argon. If the ball doesn't drop, that means there's a leak in the gas line that needs to be fixed. If it does drop, that means the line leading up to the machine's valve is properly filled with argon. 7. Choose the right tungsten rod. For DC TIG, you should use a red-tipped tungsten. For AC TIG, use a green-tipped tungsten. Make sure the tungsten matches the collet and collet body. Make sure the ceramic cup is intact and that the back cap is tightened. Secure the tungsten firmly. It shouldn't pull back when it makes contact. To ensure good conductivity, sharpen the tungsten to a point. 8. Clamp the ground close to the welding area. The closer, the better. Both the clamping point and the welding point need to be clean and free of any contaminants to ensure good conductivity. After you finish the preparations, turn on the machine. Check to see if the indicators light up. Make sure the fan is running and check for any error codes or warning lights. If errors happen, don't just brush them off. Look into them carefully. For instance, if there's a flow alarm, check if you're using an air-cooled or water-cooled torch. Air-cooled torch, check it. Water-cooled torch, check cooling tank powered and water flows. Check water level. Make sure the cooling tank is powered on and that the water circulation is working properly. Please ensure that there's a sufficient amount of return water present in the bucket for optimal performance. If the torch does nothing, check the switch circuit. If there's no gas, no high frequency, and no arc, the first thing to do is check if the torch switch circuit is functioning properly. Unplug the torch switch aviation connector and set your multimeter to continuity mode, which is often referred to as the beep test. Insert the 2 probes into the torch switch aviation connector. Press the torch switch. It should beep to indicate that there's a proper short circuit. When you release the torch switch, it should stop beeping, indicating an open circuit. If you confirm that the torch switch is malfunctioning, you'll need to either repair or replace it. If the torch switch is fine, then the issue is likely with the welding machine. Try switching the machine to MMA welding mode and use a multimeter to check if the open circuit voltage is normal. If there's no open circuit voltage, reach out to the original seller for repair or replacement. If you press the torch and there's gas and high frequency output, but no arc is generated, first make sure that the ground clamp is properly connected to the workpiece. Make sure both the ground clamp and the welding area are clean and polished, and try slightly increasing the welding current. If these steps don't resolve the issue, check the intensity of the high frequency. Ideal intensity should look like the forked lightning of a Naga in Warcraft 3, not the chain lightning of a prophet. In other words, it should be strong and branched, not weak and thin. If the high frequency is weak and you have expertise in power electronics, you may open it. Press the torch switch from a distance. With the seller's consent, you can open the machine's case. Dim the lighting and press the torch switch from a distance. Check the strength of the high-frequency arc at the arc starting electrode on the high-frequency board. Check components like the output inductor, high-frequency arc start coil, and torch output terminals. If you suddenly see mysterious arcs appearing in these areas, it indicates that there are insulation issues causing high-frequency leakage, which weakens the output and makes it difficult to start the arc. If there's no leakage, you can try adjusting the electrode gap on the high-frequency board. Just make sure to turn off the machine first. Short circuit. The electrode ends with a conductive object to discharge it forcibly before making any adjustments. Slightly widening the gap can help increase the high-frequency voltage. But don't make it too wide, because if the gap is too wide, it can cause strong electromagnetic interference, EMI, which might lead to malfunctions, freezing, or restarts. If you press the torch and there's gas, high frequency, and an arc, but the arc breaks off shortly after starting, ensure proper ground clamp connection and clean welding area. Slightly increase welding current and verify correct tungsten electrode. Try slightly increasing the welding current and verify the tungsten electrode is correct. For example, using a green-tip tungsten electrode for DC TIG welding can lead to problems. Another possibility is that machine interference is causing the protection system to kick in and stop the output. Check if there are any abnormal flashing lights, resets, erratic displays, reboots, or alarm indicators on the machine's panel when the arc breaks. If the gas flow stops completely, even without post-flow interference might be the cause. Interference is tricky, often from machines. Professional help is best. We've seen cases where welding machines located near MRI equipment in hospitals affected by interference. Overall, interference problems are tough to fix by yourself. It's best to get professional after-sales support for help. Welding issues can take many different forms. Analyze them logically and try not to jump to conclusions. Follow us for more knowledge, insights, and experience about welding. See you next time. I hope you have a great day ahead. Bye-bye.